So welcome back to the Advanced Programming using Java course for the remaining of the first lecture. Now the first chapter of the course will be an introduction to or a revision on basic Java programming. In this chapter we will review the main concepts of programming using Java. These concepts you should have taken them in the Programming 2 P2 course. We will review them in this first chapter before we can start with the new material, new stuff in the course related at the beginning to the Java graphical user interface. So I will be covering part of this chapter, part of the introductory chapter in the remaining of this lecture, and I will cover the remaining part of the chapter in the next lecture. We will start from the basics of programming. Let's start at the beginning with loops. So you all know from P1 that loops are used for repeating a certain action in programming. So once we want to repeat any statement, any action several times, we use a loop. Now, as you all know, we have two main loops in programming in general, in most programming languages, which are the for loop and the while loop. What's the main difference between the for loop and the while loop? The main difference is that we generally use the for loop when we want to repeat a certain action or a certain statement a known amount of times. So we know specifically the number of times that we want to repeat the statement. In this case, in most of these cases, we prefer to use a for loop. In the cases that the stopping of the repetition is based on an event, action, a certain condition, so we don't know when this condition might happen, then it's preferred to use the while loop. In all cases, for and while are used interchangeably. So each time you use a for, you can use a while, and vice versa. So they are not specific for certain situations, but we can say in general that what I have said, that when we know the specific number of repetitions, we prefer generally to use a for. When we don't know the number of repetitions, we prefer to use a while. For example, here we know that we want to repeat the actions inside this loop until the value of count becomes greater than or equal to 100. So in this case, if I see that I have count plus plus, I know that I'm going to repeat this loop 100 times from 0 to 99, because at 100 I will stop. So here I know exactly 100 times. But suppose that the value of count is not incremented by 1. There is a specific function in which you change the value of count according to this function. In this case, you don't know the number of repetitions. So this is a situation in which the number of times the while will be repeated is not known. So I prefer to use while in this case. But I can do this type of repetition using while or for, no problem. Okay, so you should be reminded, and you should be accustomed and very used to using the while and the for loops. These are the basics of programming. Another form of while is the do while. So the do while is the same as the while, but we have a do statement at the beginning, and then the while condition is put at the end of the loop, as you can see here. The main difference between the do while and the while is that in the while there is a possibility that I do not enter inside the while, and that I might exit the while from the beginning without doing any iteration at all. So the number of iterations might be 0. On the other hand, in the do while, you should do the iteration at least one time. So you first enter the do, you do the statements, and then you check the condition. If the condition is wrong, then you exit the do while. But before exiting, you have already done the body of the do, so you have done the body of the loop at least one time. Okay, so here in while, you first check the condition, and then if the condition is true, you enter inside the loop. In the do while, you enter inside the loop, you do the loop, and then you check the condition. If the condition is wrong, then you don't go into another iteration, you exit. Another form of loops is the for loop. It is, as I said, interchangeable with while. You can use while for and for while. The syntax of the for loop is a little bit different. In while, you just say while and then you put the condition between parentheses. Here in the for loop, you have for, and then between the parentheses, you have three different types of statements. You have the initialization statement, then you have the condition statement, and then you have the incrementation statement. So in each one of these, you do something different. First, in the initialization, you execute this statement only once before you enter the loop. So before you enter inside the body of the for loop, you execute the initialization statement here. Then each time you perform the loop, you check the condition. If the condition is true, then you enter inside the loop and perform the loop another time. Then you check the condition and so on. If you finish the loop and then you check the condition and find that the condition is false, then you exit the loop. Okay, so and the incrementation phase is when you check the condition and find that the condition is true. So before you enter the loop, you do the incrementation phase. Something important to know is that in Java, we support multiple statements inside the initialization and the increment statements. So we can have here, instead of having only a single initialization for integer I equal to 1, we can say for integer I equal to 0, for example, and j also is equal to 0. So both of these are inside the initialization phase. So the three different statements are separated by semicolons. Inside each statement, we can have multiple statements, as you can see here. Each one of these statements is an initialization statement. So we are initializing both I and j to 0. The initialization statements are separated by a gamma. Also in the increment, we are here incrementing both I and j. So we have two incrementation statements instead of one. Okay, so this is possible in Java, although it is not very well used. It is rarely used because programmers prefer to do only a single initialization, single increment, and then do all the other stuff inside the body of it. This is an example of how everything that we can do in a while we can do in a for, and vice versa. So in some cases we might want to write a loop that will be repeated forever. It will be repeated indefinitely. So this type of loop is the while true loop. Equivalent to this in Java, we can say for empty initialization, empty condition, and empty increment. So when we put everything is empty, there is nothing to check for condition, nothing to initialize. So we'll be repeating the body of the loop indefinitely. So these two are equivalent to each other, while true and for empty statements inside the body, inside the part of the for at the beginning. Inside loops, we have two main statements that are very important for loops, which are the break statement and the continue statement. So what are the specifications and the significance of break and continue? If we want to stop the iterations of the loop if a certain condition is satisfied, we put a break statement inside an if statement for that condition. So here, for example, there is a number called number. So here we have a parameter called number, and we are saying that while number is less than 20, we want to increment number plus plus, and then we want to add some number we added to sum. So when sum reaches a value greater than or equal to 100, we want to stop the loop. We want to stop iterating the loop, exit the loop. So we put here break, which means that we start with sum equal to 0 and number equal to 0. So we say while number is less than 20, number is 0 is still less than 20, so we enter inside the loop. We increment number, number becomes 1. Then we say add to some number. So sum was 0, now it will become 1. So sum is 1. So if sum is greater than 100, then we break. Now sum is 1, it's still less than 100, so we will not break. We will not go inside the body of the if. We will exit the if and then go back to the beginning of the while. Then we will check number. Number is still 1, so we will enter again inside the loop. Still less than 20, we will again enter again inside the loop. We increment number plus 1, number will become 2. Then we will add to the sum the value of number. So sum was 1, we added to it 2, sum becomes 3. So if sum is greater than 100, we break from the loop. Okay, so sum here is still 3, it's still less than 100, so we will not break, we will continue with another iteration. We will keep doing this until we say reach a value of sum which is greater than or equal 100. In this case, we will not go and execute the while loop again. When we reach a condition that is true here and we enter inside the body of the if and we execute the break makes us exit the while loop and continue after the while loop. Another statement is the continue statement. The difference between break and continue is that in break we completely exit the loop, while in continue we don't exit the loop, we just skip the current iteration and we continue with the next iteration. So continue leads us to skip all the statements until we reach the end of this iteration, and then we will continue with the next iteration. Okay, so here, for example, we are checking if number equal to 10 or number equal to 11. We are saying continue. So when we reach the value of number which is equal to 10 or equal to 11, we don't add, in this case, a number to sum. So we skip this statement. One number will become equal to 10 or 11. We skip this statement and then go to the end of the iteration and then continue from the beginning of the loop and we'll check number again. So break will completely exit the loop, while continue will skip the current iteration and then we will continue with the next iteration. So that was a revision about loop structures in programming. Let's revise a little bit the definition of methods, functions, how we use them, what are their characteristics, and so on. So in programming, a method or a function is a collection of statements that are grouped together inside a single block to perform a certain operation that is isolated from other operations. For example, we have here a method or a function called max. This function takes as inputs two parameters, two integers, integer num1, integer num2, and it returns as an output of the function an integer here. So here the return type, data type of the function, and here are the inputs to the function. Now the body of the function, as you can see, contains several statements that are enclosed between curly braces. Here we define a parameter of type integer called result. Then we check if num1 is greater than num2, then we say that result is equal to num1. Else, which means that num2 is greater, then we put result equal to num2. Then we will return result which will be the maximum of num1 and num2. Okay, so when we want to invoke this method from the main function, we say integer z equal maximum of x and y. Here x and y will be defined as values inside the main function. So you pass these values into the invocation of the method and you return the result from the method, the return value of the method. You return it and put it inside the parameter z in the main. So there is a difference between the actual parameter that you pass them and between the formal parameters that are defined in the signature of the method. The formal parameters, they define general parameters that don't have specific values. Their values depend on the values of the parameters that you pass them to the function. These are called formal parameters. They don't have specific values when you create and define the function. Now, when you execute the function, you pass to it parameters that have specific values. You have defined them. These are called actual parameters or arguments. The signature of the method is the combination of the method name and the parameter list of the method. Public static integer max, integer num1, comma integer num2. Until here we say this is called the signature of the method. The signature of the method is very important for classes. In some classes we can create a signature of the method alone, and then we write the body of the method after that. Also in Java, signature is very important because we have the concept of interfaces in Java. We will talk about interfaces later. So in interfaces, we have only signatures of methods. We don't have body of methods. We create only signature of methods inside interfaces. We already talked about formal and actual parameters. With respect to the calling methods, so as you can see here is an example how you call a function in Java. You pass the value of parameters that you have defined. You define them and give them values. So example here, I equal to 5, integer j equal to 2. So I and j now have values. Then you say maximum of I and j, max of I and j. So you are passing two parameters that have two values that you have specified. Once you call the function and pass to it the actual parameters, these parameters are put in place of the formal parameters. So now the formal parameters will have the values of the actual parameters in the execution of the method. And when you execute the body of the methods, num1 will be equal to I, which is 5, and num2 will be equal to j, which is 2. And you execute the method based on num1 equal to I and num2 equal to j, and you return the result into the value k here, the variable k. So if you try to pass I and j to the function without initializing them, without giving them values, the Java will give you an error because you cannot use actual parameters without specifying value for them. Something important in Java is that when you have a return statement inside a method, then you are obliged to specify a return value for all possible return statements or return paths. What does this mean? So suppose here that I have a function called sign. I pass to it an integer n. I'm saying here if n is greater than 0, return 1. Else if n equal to 0, return 0. Else if n less than 0, return minus 1. So in this case, Java will not understand that these are only the three possible cases for n, either greater than 0 or equal to 0 or less than 0. So we logically know that only these three possible values, n will never have any other possible value other than these three values, either less than 0 or equal 0 or greater than 0. But the Java compiler will not understand this. It will detect that you haven't put an else at the end of this three statement, else if else, if else if else if. You haven't put a final else here. So it might say that if n have any other value other than these three values, I don't know what I shall return in this case. So it will give for you an error. Once you put here an else alone without else unless 0, if you remove this one, saying that in all other cases other than greater than 0 and equal to 0, I want to return minus 1. Although these two are the same for us, for Java it's totally different. For Java here you have specified a final else without anything, meaning that in all other cases other than this case and this case you return minus 1. So this is okay for Java. You have specified a return statement for each possible return condition. Okay. While in this case, Java might think that there might be other cases other than n greater than 0, n equals 0, and n less than 0. So you haven't specified a return value for these other cases, so it will give you a. So this is something that you should consider when you have a function that contain a return statement. You might get an error because Java might tell you haven't specified a return value for all return conditions. In methods, we want to know the concept of what we call the stack, the program stack. If you have taken operating system with me, you should have an idea about the program stack and how is it used. Here we just want to know the general overview of it. So the program stack is a memory location in which you save the values of variables inside functions. Each function will have several parameters. Each parameter will have a value. So you save the values of the parameters inside functions inside the program stack. Also, when you call a function from another function, so the program needs to know what is the function that you have called, what is the address, the memory address of the function that you have called, and what is the memory address that you should return to after you finish the call. So all of these return addresses and function addresses are also saved in the program stack, in addition to the values of the parameters inside functions and the values that you pass to other functions. All of these are saved inside the program stack. So you just need to know an overview about this, why it is used. Another thing related to methods is the concept of overloading and overriding methods. We will see overriding in a later slide. Let's talk here at overloading. What do we mean by overloading a method? So overloading means using the same method, the same name of the method, in another method with different parameters of different type of parameters. So you can see here, for example, I'm defining a method called max. So previously I have defined a method called max here. So this is method max. You can see here public static integer max, integer num1, integer num2. So I'm passing to the method as an input two integer values, and I'm returning from the method an integer value. Here in this overrided method, I'm creating another method, the same name, it's called max, but I'm passing to it two doubles and I'm returning a double value. So this is the same method because it has the same method name, but it's not the same method because it has different types of parameters that you are passing, a different return parameter type. So this method is called overloaded method of max. Overloaded method of max. Okay, so I can use the two methods inside the same class. Inside the same class, I can write method max, which takes two integer, another method with the same name max, which takes two double values. These two methods are called overloaded methods. They are considered by the program as two different methods, although they have the same name. So how can I do overloading? By using one of three methods. Either that the data type of the parameters are different. So for example, in the previous max, data type was integer. Here the data type is double. So the first type of overloading is to use different data type in the input parameters. The second method of overloading is to use different number of parameters. For example, the first max had two inputs, integer num1, integer num2. Suppose this max have integer num1, integer num2, integer num3, three inputs. So this will be considered an overloaded method because the number of inputs is different. Okay, so either the data type or the number of inputs is different, it will be considered an overloaded method. A third type of overloading is to use a different order of the parameters. So for example, if I have public static integer max, then I have here integer num1, double num2. So if integer and double, if you create another function max, in which you have double than integer, the order of the parameters is different, it will be considered also an overloaded. So these are three different ways to do overloading in Java. It's very important to know about the scope of a variable in Java. The scope is the area in which a variable is identified and can be known to the program. Outside of the scope, the variable will not be known to the program. For example, here, when I say inside the main, for integer I equal to 1, I less than 10, I plus plus. The scope of I is the for loop. So I is identified from the beginning of the for loop until the finish of the for loop. Here. Okay, so the whole for loop contains the scope of I. I will be known inside this scope. Anywhere outside the for loop, here or here, the program will not be able to identify I, will not know I. It will give you an error if you try to use I here or here. It's only known inside the for loop. If inside the for loop you specify, you write integer j, so the scope of j will be from the time you identify j until the end of the loop. In these statements, you can use J. Outside these statements here or here, you cannot use J. So you can use the same integer with the same name in two different scopes. So here I have two different for loops that are separate from each other. In both of them, I'm using the same integer I. This is okay because the scope of this I is from here to here. Outside this first for loop, I is not known. If in another for loop I use I another time, then it is okay because this is another variable I that has a different scope from the first I, totally different. Now, if I have integer I inside the main or inside the method, so I will be known from its beginning until the end of the method. So if you have for loop inside the method, you cannot use I again because you will have two variables with the same name that they have overlapping scopes. This will result in an error by the Java code. So this will be everything for this lecture. We have finished the first part of the introduction to revision to Java programming. In the next lecture, I will continue with the remaining of the revision. I will talk about arrays, classes, and characteristics of classes and so on.